concept because it in some way lays the foundation of loading data from an external source, like an external cloud provider. So therefore we want to see how this works. To do this, we want to now create a new worksheet. So we can just go back to the home menu, go to worksheets, and then just create a new SQL worksheet. When you are already in the worksheet section, you could also just create a new worksheet by clicking here on this plus icon. And then we can also rename this. So here we can either double click in it, or we can also just click on these three dots and then say rename. So here we want to say, for example, create stage, so that we can reuse this, and we can also move it into this first folder. So we can click on these three dots and then we could say move into first folder. So now in the resources, you can also find all of the commands that we are going to execute here and that we are going to have a look at. So before we dive into the stages, we want to create and set up a database. We call it ManageDB. This is also in some way a best practice so that we can store all of the administrative objects, like for example stages, in a dedicated database. So therefore, we will first execute this. So you can see here, we manage here in this database the stage object, file format objects, what we are also going to talk about in a bit. So therefore, let's highlight this, execute it, and we will have our database created. So here you might want to refresh and then this database should appear. Of course, now it's empty apart from, of course, the default schemas that are there. And we now want to set up our stage as we have said. So the command for this is, before we do this, here create or replace stage. But we can also, if we want to organize this a little bit better, also create schemas. So here a schema for our stages. So like this, we can further organize and break down our database. So let's also execute this. And then we see this should also be available after we refresh. And then we want to go ahead and create our stage. So again, the stage contains all of the necessary information to load data from an external source. So this could be, for example, as we can see in here, the location. So in our case, it is an S3 bucket. So therefore we have the URL, but it can also be additional things like, of course, the access. In this case, it could be credentials. So when this is an S3 bucket, we can have an AWS key ID and an AWS secret key. So in this case, we want to go ahead and create this stage like this. So we just use create or replace stage, the fully qualified name of the stage, so of the object. We have this called AWS stage. That's what we choose as a name for our stage. And then just the schema and the database. So let's select it, execute it, and then we will see that in this schema we have now this stage. So you can see it's broken down into stages. We can select it, and here you can see also some information. So here the cloud is AWS, the region, and so on, because this is actually a bucket that actually exists. So here this could be recognized already. And now, of course, when we have created a stage, we see in a second how we load, of course, the data from the stage as well. But first of all, we can have a closer look at the stage. So for this, we can use the describe command. So I execute this, and then we can see now how this stage object looks like. So let's have a closer look at this. We can see we have here different types of properties. For example, the data type. In here we have, this is the default value, a CSV file. And then how is the file delimited? So here the records, how are the records delimited and how are the fields delimited? So these are default values because we have not specified them. And in this case, if we scroll down, we can also see additional things like the encoding and also, lots of properties that actually most of them we are also going to talk about later on. And also we should see here the location. So if we have a closer look at this, we can see that there is also the stage location, so the URL. And in this case, it is our S3 bucket. And then we have also the AWS key ID. So this is just basically the credentials. Actually, it's not a best practice to store the credentials right into our stage. So it would be better to create a so-called storage integration object. So that's a different object. And we talk about this also later on. So this is just a best practice, but it is of course possible to store the credentials here. And for now, this is what we are going to do before we later on talk about the, a little bit more secure way as well. All right, so we have now created and had a look at our stage object. And if we would want to change it, we could also use the alter command. So you can see here, since we use currently the context of manage_db external stages, we don't need to use this fully qualified stage name, but we can just use this name like this without database and schema. And if we would want to alter it, we just use alter, and then we say set. We use the property that we want to change, and then we can set it to new values. So in this case, we could, for example, change it to this one, and this could be also changed to this so that it would be different. So for now it's this, but we could also say we want to change it. We execute it with Control Enter. We describe it again, and then the values should be different. So now we should have different values. In this case, we can see it has been also indeed changed. But now we also, of course, want to actually use this. So therefore, we are going to create it from scratch, because this one is actually a publicly available stage. So, or publicly available S3 bucket to be more precise. And the stage is pointing to this publicly available bucket. And therefore, we don't actually need those credentials. So therefore, we will just quickly create and replace it again. And now we want to have a look at what are actually now the files in this stage, because this is an actual stage, an actual bucket that actually exists. And we can see in this case, we indeed have here 3 different files available. So we want to now see in the next lecture how we can load those files into our Snowflake database. And for this, we are going to use the copy into command. And this is what we are going to have a look at. And one last note before we go to the next lecture, you already see that the stages, unless we use the describe command, but usually when we want to refer to the stages, the external stages, we use this @ symbol. So this is true with the copy command and also with the list command. So this is just how this is referred to. All right, and in the next lecture, we now want to see how we can load the data. Fully created our stage, and we've seen that there are 3 files in this stage. We want to go ahead and copy the data. So we want to load it into Snowflake, and we do this using the very important copy command. So again, we can download all of the commands from the resources in this lecture. And in this case, what we want to do is we want to load this loan payments data. So this is just basically a CSV file that contains some order data. So we have the profit amount, quantity, category, and so on. And we want to load this into our database. And therefore, first of all, we should make sure that there's a table that can actually hold this data in Snowflake. So we do this just using the create table command. So we create this orders table and we put this into our first DB database. So therefore, let's just first of all select this, we execute it, and the table should be created. So we should see the table should be there in the public schema. So if we expand it, we should be able to see now this table here. And of course, at the moment, this table should be empty. So if I now try to query from this, I should see that there is actually really no data in this table. And now we want to execute our first copy command. So let's first of all have a little bit of a look at the structure. This is just very simple. We say copy into, and then afterwards the table where we want to copy into. And then of course the source, where do we want to copy from? And of course we mention our stage. This is where we copy from. This contains the location and all of the additional information. And of course also external stages always are referred to with this @ symbol. And also we are using in this case not the fully qualified stage name because we have already selected this as part of our context. We could also mention it, so then it would look like this. This is also of course possible, and this is in our case not a difference at all. So after the copy command, we can also specify the file format. So this is also actually per default part of our stage object. When we describe it, we see these file format properties, but we can also in a given copy command override these properties. Or if we want to be sure that they are used, we can anyways just specify them so that we are sure everything is as we expect, and then those properties will be used. Additionally, we will also see this in a bit, we can also create this as a separate object. So this will be a file format object, and it can be also used in the same way, and we see how this works in a second. But for now, we just want to add those properties using just a copy command, and we specify it just right after it. Okay, so we have a CSV file, comma separated, and there is a header. So we say this is 1, which means this is true and the header should be skipped, because in our case we see that there's a header, so we don't want to load this as data, therefore we set this to 1. All right, so now let's go ahead and just create or execute this command and see if we are able to load the data into our table. And indeed we see this is not working and we get an error message. So let's have a look at what this says. Number of columns in file 2 does not match that of the corresponding table. So if we have a look at our table, we can see the orders table has actually 6 columns. But now the file where we want to load has only 2 columns. So this is strange, and actually it's not surprising, because if we have a look at the external stage, so we list the files in this stage using the list command. This is something that we should do and check. We can see that there are actually 3 different files. And of course, Snowflake is trying to load all of them if we don't specify anything else. And this is where the error comes from. So therefore, in our case, we should execute this command with specifying which files exactly should be loaded. We can do this right in the copy command. After the file format, we specify files, and then in the parentheses and in the single quotes, we can mention the file names. We could also mention additional files. For example, we have maybe the sample data. This could be also added. But in our case, of course, we only want to load the orders detail. So this is what we actually want to load. All right, so now let's try this again using the files property to specify what we want to load. And indeed, we see all of the rows now have been loaded. This is what has been loaded. So we can see that's the file, and we haven't seen any errors. So now if we have a look at the table, we should see that now there should be some data in this table. So if we execute it, we see indeed we have now successfully done or executed our first copy command and loaded our data. Additionally, we can not only specify one or multiple files, but we can also load it using a pattern. For example, with these asterisks, these are basically acting as a wildcard. So this would mean that any file that contains this order, so this pattern of characters, so we use this dot asterisk, and these are the wildcards. So in this case, we would load everything that contains order. And of course, if we list the files again, we should see that in our case, this should be also this same file. So we list it again, and we see this should be the only one that should be loaded here, because this is the only one that contains order. So therefore, if we would execute it like this, we would expect that there would be this file loaded again. But now we get this status message, which shows one important property or feature of the copy command, which is that Snowflake is actually collecting metadata about what files have already been loaded into a given table, and then it will skip those files. So it will not process them. We have some ways around of modifying this and enforcing that it will be anyways loaded again, but something again we look at later on. But per default, this is actually a smart behavior. So that's the default behavior. A file that has been already loaded into a table will not be loaded again. So if we would, of course, recreate this table, so we can just say we want to delete it basically, we drop it, and then we create it again. So now it should be of course empty, and this is now a completely fresh table because we have completely recreated it. Now it should load this. So again, using dot asterisk as wildcards, we would now expect that also this one file would be loaded, and indeed this is what has happened. So this were the basic structure of the copy command. And in a copy command, we can also transform data actually during the load. So this is something that can be quite useful and part of our overall strategy when loading data. And how this would work, we now also want to have a look. In this lecture, we want to have a look at how we can transform data during the copy command. So during loading data, this can be sometimes very useful so that we can just directly get the data transformed and ready to be used in our database. So this can be part of our ETL strategy. And to do this, I will just again go ahead and copy the commands that we are going to use. Again, you'll find them in the resources of this lecture. So how does this work? The thing about this is that we can use a select in the copy command. So instead of just referring to the entire file, we can say from, we open the parentheses, and then basically we have a select statement. So this can be now using only a subset of columns. So for example, we can say I want to have the first column, and we refer to the columns by using the column number, so the column index. So $1 means the first column, so this would be the order ID, and then $2 means the second column. In this case, it would be amount. So in this case, if we would have only the order ID and the amount, so let's create this table as our orders example table, we would be able to load only this subset. So using the select command, one option would be to use only a subset of our columns, and everything else is the same. And note that also here in this select statement, we are using from, and here as a best practice, we use this as the not capitalized letters just for readability. So this is something that just shows us that this is just part of the select instead of part of our copy command. So in this case, we now want to execute this. But first of all, we want to set up this table, of course, and then we can use the copy command to load the data into our table. Let's have a look at the result. So if we now query from this table, we see everything has worked fine. So we want to see what's now in this table. And of course, indeed, we see now there are just those two columns. So it seems like it has worked well. So this was a good example. We have selected a subset and copied only the subset in our data. Maybe sometimes we have a file that contains hundreds of columns, but we only want to have the first two columns. Then we don't need to waste so many resources. So we can just focus on those two columns. So this can be very useful. Another example is we can use a SQL function. For example, we want to use, in our case, a case function. In this case, if we have a look at our original file, we can see that the amount, or to be more precise, also actually the profit, so our third column, sometimes contains negative values. And now we just want to get a flag basically, so a label that tells us, is it profitable or is it not profitable? And we want to just categorize everything that is negative as not profitable. So for this, we just use a simple case. And note that while we can use SQL functions in the copy command, we cannot use all of them. So there's just a subset of the SQL functions that work as copy transformations. So if you want to have this full list, you can also refer to this documentation in Snowflake where they show the subset of those functions. So you can see there are quite a lot of functions, but it is just a subset and we cannot use all of them. This is just something that is worth noting. And now let's have a look at how we would do this. So again, we just structure it a bit nicer here. We use the not capitalized select here. And then afterwards, we use the first three columns. So this is why we have them here just like we had them before. Let's actually go ahead and replace our existing table so that we can have the table refreshed with our new structure. And then as the third column, we use this case when function. And in here, in this case, when function, we are also using the cast function. The cast function is just casting the value, meaning it is changing the data type of the column. So this is done because we want to compare it against a numerical value. So therefore, we have to cast, so we have to change the data type of this column. So column number 3 is the profit, to integer. And implicitly, when we load the data, this was already done in the copy command because this was the data type here. But since we want to use it in the case function, it is just using per default in CSV files always the string value. So it's always interpreted as string unless it would implicitly already cast it, because this is what the data type of the column expects. So then we would not have to explicitly do that. But if we would want to use it in a case or another function, we would have to cast it to an integer first in this CSV file. So in this case, if it's less than 0, it will just be not profitable, and in all other cases, it will be profitable. And don't forget the end of the case, so that this ends as the column, and then afterwards we just have again the from and everything that we have also used previously. So let's now go ahead and execute this to have a look again at the result. We see this has worked very nice, and we can now also have a look at the table, and indeed we see those negative values have the label not profitable and the positive ones have the label profitable. So this has worked well, which is very nice. And now one last example. We want to see how we can also use the substring function. So this is a function where we can just extract a substring of a text. So in our case, if we have a look at the column number 5, this is the category. And in here, we might want to, because maybe our report expects just the first 5 digits. So we want to just extract here the first 5 characters, and therefore we use the substring function. This means we apply it on the function. This is the first argument. So here column number 5, and then the starting point and the end point. So we start from the first character and we stop at the 5th character. So we extract the first 5 characters. And then everything again is the same. By the way, this is something that I also want to mention. Here we are just using an alias. So this makes it just a little bit easier when we work here. And this is again a best practice, even though it is not necessary, but it is good to use those aliases as a best practice. All right, so now let's again recreate our table for our last example, and now also copy this using the substring, and then again, of course, have a look at the result, what we have loaded, so that we have seen we have done this successfully, and we have now applied a few transformations on the fly during the load, which can be very useful sometimes in some cases. And now that we have seen how this works, we want to have a look at a few other options during the load, which